Teak 2C is in the linear category, and it's our second writing equations teak. It says that students are expected to write linear equations in two variables, given a table of values, a graph, and a verbal description. So this time they're not given points and slopes, they're given more real-world scenarios, tables, graphs, and verbal descriptions to create these lines or equations from. Now, when we're given a table of values, we're going to really want to be using one of the two forms of either point slope form or slope intercept form. We teach the students in slope intercept form first, so that's what I'm going to go over here because it's more straightforward. And when I am trying to use slope intercept form, which is again is this y equals mx plus b format, I need to know a slope and a y-intercept. From tables, graphs, and equations, I can find all of those things. So what I need to do is figure out what the slope is. Good thing I already have a formula for that. From my formula chart, I know that the slope is y2 minus y1 over x2 minus x1. And my table helps me put those pieces where they belong. They're already labeled as x's and y's. I can just put them in the formula. It's going to be -6 minus -8 all over -1 minus -2. Subtracting negatives is confusing, so we're just going to make this easier on our brain. Negative times negative is a positive, so subtracting a negative is a positive. -6 plus 8 is 2. -1 plus 2 is 1, so my slope is just 2. Easy enough? Now the y-intercept from a table, we're going to be looking for the b to be partnered with 0. That's how I know where my y-intercept is. And just straight up looking at this table, I know that my y-intercept, my b value, is -4. So I can write an equation for this line that's y equals the slope plus the y-intercept. So my y-intercept is negative, so plus my y-intercept. That's it. Slope and y-intercept. Now this can also be given to you in a graph form. Again, we want to find the slope and the y-intercept to plug in here. Using previous skills, we know that the slope is the rise and the run, or y2 minus y1 over x2 minus x1. Here's a point, there's a point. To find the slope, I went up 2 and I went over 1. To the right, so I'm going to have a rise of 2 over 1 or 2, and I would look for the y-intercept, and I'm just looking for the point where the graph crosses the y-axis. This graph, this line that's red, crosses the y-axis at -4, so I know immediately that my b value is -4, and just like on the previous table, these are all equivalent, we would find that the equation of this line is still 2x minus 4. So whether they give me a table of information or a graph of information, I can still write the same equations. Now, a verbal description is the real-world aspect here. We're actually going to be giving students scenarios like this and asking them to write the equations. You're going to be looking for keywords to find the slope because, yet again, we're just filling in this formula. The keywords for slope that we're going to look for are the words per, or each, or every, or a rate. And the keywords for your y-intercept are begin, initial, or starting. Okay, so this scenario says a small child spent $4 buying supplies for his lemonade stand and is selling the cups of lemonade to his neighbors for $2 each. So the keyword I physically see right here is each, which is going to help me know that that is my slope, $2 each. That's what I'm going to use as the M, is 2 or $2. I don't see the words begin or initial, but if you think about this in a real world context, this small child had to spend money before making money. So they started by spending $4. Spending money is negative, gaining money is positive. So really, we now know that my B is -4 because I spent $4 when I started, and that my slope is $2 each lemonade. So yet again, this can be represented in the same function. I spent $4 to begin with, but I'm making $2 back for every lemonade I sell. Again, these are on our formula chart, so all these forms of an equation here for our linear unit are going to be very helpful. It doesn't have rise over run on it on the formula chart, but students generally remember that. This formula still works for all tables and graphs. So if we see an example from a STAR test, it says a table represents some points on the graph of a linear function. There's the graph. Which equation best represents the same relationship? Now, if we notice, all of these answer choices are written in point-slope form. We identify that, we match it up on our formula chart, and we know exactly what we need. We need some slopes, and we need some points to find point-slope format. Well, table, easy. I already know how to find the slope from a table. We've practiced this. We know that my slope is y2 minus y1 over x2 minus x1. We consult our calculator because those are big numbers, but we're just going to change this minus and minus to a plus to 268 and minus and minus to a plus, so that we would ask our calculator or our brain, what is 196, negative 196 plus 268, and we'd get 72. We'd also ask it what's negative 14 plus 20, we'd get 6. 72 divided by 6, our slope is 12. So immediately we cross out two answer choices. It's definitely not F or G because they do not have the correct slope here. Then all we need to do is make sure they plugged in a point correctly. In the answer choices, they're trying to plug in this first point, negative 20 and negative 268. Well, to negative 268 is the y. So we need to make sure that the negative 268 is plugged in correctly. We would write this equation as y minus negative 268 is equal to 12 times x minus, can't see my writing over there, sorry, x minus negative 20. Minus a negative, fine but confusing. This is going to be y plus 268 equal to 12 times x plus 20. Again, sorry, I had to change colors. So we know that H is our correct answer. It uses the right slope and point from this table. We might also be given this for point slope form from a graph. Okay, almost simpler than using slope intercept form. I can find my slope by finding 2 points, find 2 good corner pieces. To go from the first point to the second point, I had to go down 3 and to the right 1. So my slope is down 3 over 1. Get rid of 2 answer choices. These are not the right slope, so it's definitely not C or D. And we just have to make sure that the point from the A and B are on the line. The point represented here is 4 and negative 7, and negative 2 and negative 1. Well, 4, negative 7 is right here. Negative 2, negative 1 is here. So obviously, A is on the line and B is not. So that's one of the graphs represented. Our last real-world problem is our scenario dealing with the word problem. It says that researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. So that first discovered kind of sounds like an initially number. So that looks like it might be my initial value or my y-intercept. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters x days since the discovery? Well, we want to write this in y equals mx plus b form. And we saw that a few of these words exist. The rate is my slope, but it says decreasing, so I'm going to make sure it's decreasing per day, and that it started with 450. We began with 450 meters for this melting glacier. None of the answer choices exactly look like this, but we can always rearrange our equations. If you just rearrange these equations, a positive 450 and a negative 0.06x, this is answer choice A. It measures the thickness of the glass. So we look for those keywords of rate. Oh, that's not a highlight. We look for the keywords of rate and first, initial, beginning. Thank you, Skeeters. We empower, we impact, we love, we are Skeeter Nation.